Question 1. In the context of managing an Exadata system, Mr. Patel observes that during a high workload period, all queries are slowing down significantly despite sufficient CPU availability on database servers. What should Mr. Patel investigate first to improve query response times in this scenario? A. The configuration and efficiency of smart flash cache on storage cells. B. The topology and speed of the InfiniBand network connecting storage cells. C. The implementation of hybrid columnar compression on data tables. D. The current ASM redundancy level used for disk groups. Answer. Correct answer. B. Explanation. The InfiniBand network in Exadata is the high-speed fabric that connects database servers and storage cells, critical for low latency and high throughput communication. If all queries slow down despite sufficient CPU, network bottlenecks often cause delays, especially since OLT depends on fast, small I/O. Checking the InfiniBand network topology, link health, and congestion helps identify if network caused the slowdown. Smart flash cache accelerates I/O but is less impactful on network-induced delays, and hybrid columnar compression benefits analytical queries more than all. ASM redundancy affects data protection, not query latency directly. Question 2. Given the circumstances, is Ramirez needs to prioritize critical database workloads over batch processing on an Exadata system to meet SLAs? Which Exadata feature should she configure to ensure high-priority workloads receive sufficient I/O resources without starving low-priority tasks? A. Is cell offload processing. B. Oracle I/O resource management IOM. C. Storage index utilization. D. ASM disk group redundancy levels. Answer. Correct answer. B. Explanation. Oracle I/O Resource Management IOM is designed to manage and prioritize I/O resources in Exadata environments, allowing the administrator to allocate bandwidth fairly or preferentially among different workloads. It ensures critical workloads get prioritized I/O throughput without completely starving low-priority processes. Cell offload processing accelerates query execution but does not directly manage allocation. Storage indexes improve query efficiency by reducing physical I/O but are unrelated to workload prioritization. ASM redundancy is about data protection, not resource management. Question 3. As demonstrated by Istakim, the database on Exadata shows high disk latency and query performance is degrading. He suspects cell offload processing is not working as expected. What is the most likely cause for cell offload to fail in improving performance? A. The database is not using hybrid columnar compression on tables. B. Smart scan is disabled or the SQL queries are not eligible for offloading. C. The InfiniBand network is running at a slower speed than configured. D. ASM disk groups are configured with external redundancy only. Answer. Correct answer. C. Explanation. Cell offload processing relies heavily on the high-speed InfiniBand network for efficient data transfer and computation offload. If the InfiniBand network is underperforming or running slower than expected, the benefit of offload processing diminishes because data transfer latency negates the gains from filtering data in the storage layer. Hybrid columnar compression helps compression and storage efficiency but is not required for offload. Smart scan eligibility is crucial, but the question points towards infrastructure issues. ASM redundancy impacts fault tolerance, not offload functionality. Question 4. When considering the addition of new database servers to an existing Exadata rack, what is the most critical step to ensure the servers are integrated properly with the storage and network environment? A. Assigning new ASM disk groups for the added servers. B. Configuring the new servers on the InfiniBand fabric with correct domain and subnet parameters. C. Updating smart flash cache settings to include the new servers. D. Creating new storage indexes on the added database servers. Answer. Correct answer. A. Explanation. Adding new database servers to Exadata requires them to be integrated into the ASM disk group environment so they can access the shared storage managed by ASM. Assigning or extending ASM disk groups ensures the new servers can redirect database files correctly. Configuring InfiniBand domains and subnets is important but generally managed at the cluster level and usually doesn't require per server domain changes. Smart flash caches. The storage cell feature, not per server. Storage indexes exist at the storage cell level and are transparent to individual database servers. Question 5. Within the framework of Oracle Exadata storage, which of the following best explains why hybrid columnar compression (HCC) significantly improves query performance for large data warehouse scans? A. HCC enables data to be scanned and filtered directly on database servers, reducing CPU overhead. B. HCC compresses data at the column level, allowing for reduced physical EO and improved smart scan effectiveness. C. HCC forces all EO through the flash cache, eliminating disk latency entirely. E. HCC modifies ASM disk group redundancy to optimize storage efficiency. Answer. Correct answer. C. Explanation. Hybrid columnar compression reduces the storage footprint of large tables by compressing data in columnar format inside Exadata storage cells. This compression enables Smart Scan to efficiently filter and return only the relevant data blocks, significantly reducing physical EO and improving query performance. The compression and scan happen within storage cells, minimizing data sent to database servers. Doesn't force all EO through flash cache. Flash cache accelerates EO but is independent of compression. ASM redundancy is unrelated to compression or query performance. Question 6. Considering the evidence, Easterly is troubleshooting an Exadata system where SQL queries return incorrect results after a storage cell failure and subsequent recovery. What is the most likely configuration issue causing this problem? A. ASM disk groups are configured with normal redundancy rather than high redundancy. B. Selkler utility was not used to reconfigure the storage servers post-failure. C. The automatic service request (ASA) feature was not enabled. D. The database was not properly restarted after storage cell recovery. Answer. Correct answer. D. Explanation. After a storage cell failure and recovery, the database must be restarted or made aware of changes to storage availability to maintain data consistency. If the database continues operating without a restart, it may have cached stale or invalid metadata, leading to incorrect query results. ASM redundancy levels affect fault tolerance but would not cause incorrect data if the disk groups are intact. The Selkler utility manages cell configuration but wouldn't directly cause incorrect query results. ASA assists in proactive support but does not affect query correctness. Question 7. The fundamental question is how Exadata Smart Flash Cache improves ALP workload performance. Which mechanism explains this best? A. It stores frequently accessed data blocks in NAND flash to reduce disk I/O latency. B. It compresses data blocks in flash cache to save storage space. C. It replaces the InfiniBand network with a faster Ethernet connection. D. It automatically increases ASM disk group redundancy during peak loads. Answer. Correct answer. C. Explanation. Exadata Smart Flash Cache caches frequently access data blocks in high-speed flash memory on storage cells, reducing latency compared to spinning disk access. This accelerates read operations, particularly for ALP workloads with small random EO patterns. However, the option stating replacement of InfiniBand with Ethernet is incorrect because Exadata relies on InfiniBand for network speed, not Ethernet. Compression in flash cache is limited, and ASM redundancy is unrelated to cache or EO acceleration. Therefore, the correct understanding focuses on latency reduction via flash memory. Question 8. Throughout the course of managing Exadata storage, which of the following best describes the function of storage indexes and their impact on query execution? A. They maintain metadata on data distribution to help Smart Scan skip irrelevant data during full table scans. B. They store redundant copies of data blocks across storage cells for fault tolerance. C. They pre-compress data blocks in the ASM disk group to speed up query execution. D. They allocate bandwidth to database clients based on priority. Answer. Correct answer. A. Explanation. Storage indexes are metadata structures maintained by Exadata storage cells to track minimum and maximum column values within disk regions. This allows Smart Scan to eliminate scanning of data blocks that do not contain qualifying rows, thus reducing physical EO and improving query performance. Redundant copies relate to ASM redundancy, not storage indexes. Precompression is managed by columnar compression, and bandwidth allocation is handled by IOM, not storage indexes. Question 9. In light of recent developments, is Sing plans to patch and upgrade her Exadata system? Which best practice should she follow to minimize downtime and avoid system instability? A. Upgrade all storage cells simultaneously to ensure uniform software versions. B. Use Oracle Enterprise Manager Cloud Control to orchestrate rolling patch updates across components. C. Disable automatic service request ASA during patching to prevent false alerts. D. Remove all ASM disk groups before applying patches to avoid disk corruption. Answer. Correct answer. B. Explanation. Oracle Enterprise Manager Cloud Control provides automation and orchestration tools that allow rolling patch upgrades on Exadata components, minimizing downtime and ensuring system stability. Upgrading all storage cells simultaneously risks prolonged downtime and potential inconsistencies. Disabling ASA is unnecessary and counterproductive since it aids in proactive issue detection. Removing ASM disk before patching is unnecessary and risky. ASM disk groups should remain intact throughout patching. Question 10. From the perspective of configuring Oracle Automatic Storage Management ASM on Exadata, which statement best explains the impact of selecting external redundancy for disk groups? A. ASM manages data mirroring internally, providing the highest fault tolerance level. B. ASM relies on external hardware RAID for redundancy, providing no data mirroring at the ASM layer. C. External redundancy automatically compresses data blocks stored in the disk group. D. External redundancy disables ASM's ability to rebalance data during disk addition or removal. Answer. Correct answer. C. Explanation. External redundancy disk groups in ASM rely entirely on external storage hardware, such as RAID controllers, to provide fault tolerance. ASM itself does not mirror data in this mode. While this approach can offer benefits in performance and simplicity, it means ASM does not provide internal redundancy. However, external redundancy does not affect compression capabilities directly. If compression is managed by a database or storage features, ASM rebalancing is available regardless of redundancy level to optimize data placement, so disabling it is incorrect. Question 11. By evaluating the performance of an Exadata storage cell, Gupta notices that SmartScan is filtering only a small percentage of the scanned data. Which factor most likely limits the effectiveness of SmartScan filtering? A. The data is highly compressed using hybrid columnar compression. B. The queries involve predicates on columns without storage indexes. C. The InfiniBand network is not functioning at full bandwidth. D. ASM disk groups are configured with high redundancy. Answer. Correct answer. B. Explanation. SmartScan's effectiveness depends on the ability to filter irrelevant data blocks before returning them to the database. This filtering is highly optimized when storage indexes track column value ranges to skip unneeded data. If queries filter on columns without storage index metadata, SmartScan must scan more blocks, reducing efficiency. Hybrid columnar compression enhances scan performance but limit filtering directly. Network bandwidth affects data transfer but not filtering logic. ASM redundancy focuses on fault tolerance unrelated to SmartScan filtering. Question 12. Under the assumption that a new Exadata system is being deployed for mixed OLP and data warehouse workloads, which architectural choice best supports this heterogeneous workload efficiently? A. Using separate ASM disks grouped with different redundancy levels optimized for OLP PWA. B. Disabling smart flash cache to favor disk throughput for data warehouse scans. C. Configuring all storage cells to use normal redundancy only. D. Setting up the InfiniBand network with multiple isolated subnets for each workload type. Answer. Correct answer. D. Explanation. Segmenting the InfiniBand network into isolated subnets allows workload isolation and optimized network resource allocation for different workload types, reducing contention and improving performance. Using separate ASM disk groups is useful but does not address network contention. Disabling smart flash cache would degrade OLP performance because flash cache accelerates small random IO. Normal redundancy may offer enough fault tolerance, especially for critical mixed workloads. Question 13. In what ways can the Oracle Exadata Deployment Assistant EDA simplify the initial setup of an Exadata rack, automating the patching and software upgrade process post-installation? B. Providing A step-by-step interactive wizard to configure networking, storage, and cluster components. C. Automatically generating and applying SQL tuning recommendations for databases. D. Replacing manual hardware installation of physical disks. Answer. Correct answer. B. Explanation. It is designed as an interactive setup assistant that guides administrators through configuring networking parameters, storage servers, cluster components, and other critical Exadata initial setup steps. It does not automate patching or upgrades, which are managed separately. SQL tuning recommendations are database tasks unrelated to initial hardware and software configuration. Physical hardware installation remains a manual process. Question 14. Based on the information that a critical database workload experiences EO starvation during peak times, what Exadata feature allows fine-tuned control to prevent this issue? A. Using ASM disk group striping policies to increase disk throughput. B. Enabling Oracle EO resource management to allocate EO bandwidth based on workload priorities. C. Increasing smart flash cache size on storage cells to cache more data. D. Applying hybrid columnar compression to reduce storage footprint. Answer. Correct answer. C. Explanation. Increasing the size of smart flash cache allows more frequently accessed data blocks to be served from fast flash memory, reducing disk EO and helping prevent EO starvation during peaks. While IO manages bandwidth allocation, it does not increase cache size or directly reduce physical EO demand. ASM striping improves throughput but cannot prioritize workloads. Compression reduces storage but may not alleviate peak EO starvation immediately. Question 15. For the purpose of diagnosing network connectivity issues between database servers and storage cells, which tool or method should the administrator use? A. Selgly utility to query storage server health and statistics. B. InfiniBand fabric diagnostic commands like IPing and ITROSA. C. Exadata utility to perform system-wide health checks. D. RLMan logs to analyze backup network failures. Answer. Correct answer. A. Explanation. Selgly is the primary command line interface for managing and troubleshooting storage cells, providing detailed information on health and connectivity at the storage server level. InfiniBand diagnostic tools such as IPing and IPTRESA are also essential for fabric-level diagnostics, but Selgly is more focused on storage-specific connectivity issues. Exadata is broader, covering overall system health but specific for network troubleshooting. RLMan logs relate to backup operations and not network issues. Question 16. While examining the steps for orderly system shutdown and startup of an Exadata cluster, Mr. O'Connor is unsure which order prevents data corruption. What is the recommended sequence? A. Shut down database instances, then storage cells, then cluster nodes. Reverse for startup. B. Power off storage cells first, then database servers, then network switches. Reverse for startup. C. Stop ASM instances last during shutdown and start ASM first during startup. D. Shut down cluster nodes simultaneously, then database and storage cells. Answer. Correct answer. C. Explanation. Proper shutdown involves first stopping database instances, followed by ASM instances, and then storage cells to ensure data integrity and consistency. ASM manages disk groups and data files, so it must be stopped after databases to allow file operations to complete safely and started before databases on startup. Powering off storage cells or cluster nodes out of order risks data corruption. Cluster nodes should not be shut down simultaneously without following the database and ASM shutdown procedure. Question 17. Through the lens of managing Exadata Smart Flash Cache, Alvarez wants to understand its limitations. Which statement correctly describes? A key limitation. A. Smart Flash Cache only accelerates write operations, not reads. B. Data cached in Flash Cache is not persisted through storage cell reboots. C. Smart Flash Cache only supports compression for all workloads. D. Flash Cache automatically encrypts all cached data by default. Answer. Correct answer. D. Explanation. Smart Flash Cache accelerates read EO predominantly, but it also benefits write EO through write-back caching. The cached data persists across reboots, ensuring cache efficiency after restarts. Compression is independent of Flash Cache, however, encryption of data in Flash Cache is not enabled by default and requires additional configuration. assuming automatic encryption as a default feature is incorrect and can lead to security misconfigurations. Question 18. When faced with a situation where a storage cell disk fails, what is the immediate recommended action to recover the cell with minimal service impact? A. Immediately remove the ASM disk group to prevent data loss. B. Use Cellclean to offline the failed disk and replace it with a new disk physically. C. Disable Smart Scan temporarily to avoid scanning corrupted data. D. Restart the entire Exadata cluster to refresh disk status. Answer. Correct answer. A. Explanation. When a disk fails, the first step is to offload its activity by offlining the disk in ASM or using Cellclean to prevent further data access errors. Physically replacing the disk must follow after safe offlining. Removing the entire ASM disk group is not recommended as it would cause data unavailability and potential data loss. Disabling Smart Scan is unrelated to disk failures and restarting the cluster is unnecessary. Single disk failure management. Question 19. To what degree does the use of automatic service request (ASA) improve Exadata system reliability? A. ASA allows automatic resolution of hardware faults without human intervention. B. ASA automatically notifies Oracle support and logs issues for proactive maintenance. C. ASA dynamically reallocates ASM disks in case of failure. D. ASA optimizes network bandwidth during peak loads. Answer. Correct answer. C. Explanation. Automatic Service Request (ASA) is primarily a proactive support feature that detects hardware fault and automatically notifies Oracle support, expediting issue resolution. It does not dynamically manage ASM disk allocation or rebalancing. Those tasks are manual or handled by ASM itself. ASA does not influence network bandwidth or load optimization. Question 20. Several experts suggest that enabling Oracle Exadata Smart Flash Cache without proper IOM configuration might lead to A. Resource contention causing degraded performance for critical workloads. B. Complete data loss due to cache corruption. C. Over-provisioning of ASM disk groups leading to redundancy conflicts. D. InfiniBand network failure due to excessive data traffic. Answer. Correct answer. B. Explanation. Smart Flash Cache accelerates EO performance by caching data blocks, but without proper configuration and monitoring, data integrity risks arise, including possible cache corruption. However, complete data loss is rare and typically prevented by Exadata safeguards. Resource contention is more related to IOM settings than cache itself. ASM disk group provisioning and redundancy are unrelated to flash cache. InfiniBand failures arise from hardware or configuration faults, not from cache size or use. Question 21. While analyzing the merits of adding new storage cells to an existing Exadata rack, Zhang considers performance impacts. What is the most important factors you should evaluate to maintain balanced system performance? A. The current InfiniBand network fabric bandwidth and potential congestion points. B. The size of Smart Flash Cache configured on existing storage cells. C. The ASM redundancy level currently set on disk groups. D. The compression ratio achieved by hybrid columnar compression on existing data. Answer. Correct answer. C. Explanation. Adding storage cells impacts ASM disk groups and data distribution. Maintaining the correct ASM redundancy level ensures data protection and balanced EO across disks. While InfiniBand bandwidth and flash cache size affect performance, they are less critical to ensuring data integrity and balanced load when adding storage. Compression ratios do not directly affect system performance balance during hardware expansion. Question 22. From multiple perspectives, Isto is configuring EO resource management (IOM) for mixed workloads. How should he assign resource plans to optimize performance? A. Prioritize all workloads with guaranteed minimum EO bandwidth and assign batch jobs lower priority. B. Assign equal EO bandwidth to all workloads to maintain fairness. C. Disable IOM to allow ASM to handle EO prioritization internally. D. Configure IOM to direct all EO to flash cache regardless of workload type. Answer. Correct answer. B. Explanation. Assigning equal bandwidth ensures fairness when workloads have similar priority levels. However, mixed workloads usually require prioritization. Disabling IOM removes fine-grained control, risking resource contention. Directing all EO to flash cache is inefficient and unrealistic since not all data fits in cache. Optimally, all workloads should have priority, but if all are critical, equal distribution may be appropriate. Question 23. When evaluating the merits of enabling hybrid columnar compression on Exadata for an alt workload, which is the primary consideration, HCC can increase CPU overhead during DML orations, possibly degrading alt performance. But HCC enhances smart flash cache hit rates for alt queries. C. HCC automatically prioritizes alt workloads in IOM. D. HCC reduces ASM redundancy requirements by compressing data blocks. Answer. Correct answer, A. Explanation. Hybrid columnar compression is optimized for read-intensive analytical workloads and compresses data in large chunks. For alt workloads with frequent inserts, updates, and deletes, compression increases EPU overhead and latency. It doesn't affect flash cache hit rates or IOM prioritization. Compression is unrelated to ASM redundancy, which focuses on fault tolerance. Question 24. Is illustrated by a recent upgrade. Mr. Fernandez wants to ensure minimal downtime during patching. Which approach best supports this goal on Exadata? A. Use rolling patches that upgrade storage cells and database servers one at a time. B. Schedule downtime to patch all components simultaneously. C. Disable ASM redundancy during patching to speed up the process. D. Apply patches only to database servers and postpone storage cell patching. Answer. Correct answer, D. Explanation. While rolling patches minimize downtime, applying patches only to database servers and postponing storage cell patching risks version mismatches and instability. Disabling ASM redundancy compromises data protection and is never recommended. Simultaneous patching increases downtime, defeating the goal. The best practice is rolling patching with careful sequencing of all components. Question 25. The relationship between Oracle ASM disk groups and Exadata storage cells is best described as A. ASM disk groups abstract physical storage provided by storage cells into logical volumes. B. ASM directly manages InfiniBand network traffic between storage cells. C. ASM configures smart flash cache parameters on storage cells. D. ASM schedules SUL queries to use cell offload processing. Answer. Correct answer, A. Explanation. ASM manages disk groups by aggregating physical storage from Exadata storage cells into logical volumes for database use. It does not control network traffic or configure flash cache, which are managed by other components. Scheduling SUL queries and offload processing are handled at the database and storage layer, not ASM. Question 26. At the heart of this issue is Cho wants to understand why some queries don't benefit from Smart Scan on Exadata. Which factor is most likely responsible? A. The SUL queries use complex joins and predicates that cannot be offloaded to storage cells. B. Smart Scan requires ASM to be configured with high redundancy. C. The InfiniBand network is segmented into multiple subnets. D. Flash cache size is insufficient to hold frequently accessed blocks. Answer. Correct answer, B. Explanation. Smart Scan is independent of ASM redundancy levels. High redundancy is about data protection and doesn't affect query offloading. Complex queries can often still benefit from Smart Scan unless unsupported features are used, but this is not linked to ASM redundancy. Network segmentation and flash cache size affect performance, but not Smart Scan eligibility. Question 27. How might one explain the need for configuring client and backup networks separately in an Exadata environment? A. To segregate production workload traffic from backup and administrative operations, avoiding contention. B. To ensure ASM redundancy levels are maintained during backups. C. To enable hybrid columnar compression during data movement. D. To allow self-lead commands to execute independently from database clients. Answer. Correct answer, C. Explanation. Client and backup networks are separated primarily to avoid traffic congestion and improve security by isolating workloads. This segregation does not directly influence compression features. ASM redundancy is unrelated to network segregation. Self-lead executes on storage cells independent of network segregation but benefits from clear network architecture. Question 20. From a practical standpoint, Exadata wants to leverage storage indexes to optimize a large query. What must be true for storage indexes to effectively reduce EOA? Queries must contain predicates on columns tracked by the storage index. B. ASM disk groups must be configured with external redundancy. C. Smart flash cache must be disabled. D. Automatic service request to assert must be enabled. Answer. Correct answer. A. Explanation. Storage indexes store metadata on column value ranges within storage cells and help Smart scan skip blocks that don't satisfy query predicates. If queries do not filter on these indexed columns, storage indexes have no effect. ASM redundancy, flash cache, and ASA do not influence the function of storage indexes directly. Question 29. To better understand Exadata's maintenance process, what is the recommended way to replace a failed physical disk in a storage cell? A. Offline the disk using Cellcli, physically replace it, then online the new disk for ASM to rebalance. B. Remove the disk from ASM disk groups before physical replacement. C. Restart the entire storage cell after replacing the disk. D. Increase Smart flash cache size before disk replacement. Answer. Correct answer. B. Explanation. The recommended procedure involves offline or dropping the disk from ASM disk groups to prevent data loss, then physically replacing the disk. After replacement, ASM will automatically rebalance data across disks. Restarting storage cells is generally unnecessary and disruptive. Increasing flash cache size is unrelated to disk replacement. Question 30. Among the various performance monitoring tools available for Exadata, which provides the most comprehensive real-time insight into storage cell health and EO activity? A. Oracle Enterprise Manager Cloud Control with Exadata plugin. B. Arman Performance Reports. C. ASM Command Line Utilities. D. SUL Start Plus Query Optimizer Statistics. Answer. Correct answer. D. Explanation. Oracle Enterprise Manager Cloud Control with the Exadata plugin offers detailed real-time monitoring for hardware and storage components, making it the best tool for storage cell health and EO activity. Arman is for backup and recovery performance. ASM utilities manage disk groups but provide limited monitoring. In SUL Start Plus Optimizer, statistics focus on query plans, not hub performance.